Hello everybody, welcome into another lesson. So today we are going to talk about the determinant of a 3 by 3 matrix by the method of expansion of cofactors. So here of course you have your typical 3 by 3 matrix with your various constants in it. So cofactors in some ways can be at times easier to deal with than the normal way of finding the matrix of a 3 by 3 determinant. And again, we can take this and apply this to a 4 by 4, 5 by 5, and even higher. But we're not going to get above a 3 by 3 in this course. Anything above that, you should probably use an advanced graphing calculator, to be honest with you. Anyway, so to deal with cofactors, first you need to find what's called the minors. The minor, so much like with the normal method, you either pick a row or column to deal with. So I went with row 1. Okay, that's what I did. I went with row 1. Now, with row 1, this is going to be called minor 1, 1, meaning this is in the first row, first column. I dealt with coefficient A. Now to find the minor, you're going to take the place of the coefficient, so like you would before, scratch out the column and the row it's in, but you don't multiply by that coefficient. You just simply take the determinant of whatever's left. Just take the determinant of whatever's left. That's your minor. Now to find the cofactor, you're going to take what the value of that minor is, that determinant. You're going to use your sign matrix and take, so in this case we would take positive of the sign of the positive of minor 1, 1, and you would get cofactor 1, 1. Let me rebuild this real quick here. I will show you. Okay. Let's see. So now, then we're going to do minor 1, 2, which means it's in the first row, second column. So to get minor 1, 2, again, I'm still dealing with coefficient B, but not directly yet, but I'm going to scratch out the column and row that occurs in. I'm just simply going to take the determinant of whatever's left, the DFGI. That's how I get minor 1, 2. Then to get cofactor 1, 2, I come to my sign matrix. That tells me I'm going to take the negative, since I'm in the first row, second column, the negative of minor 1, 2, the negative of that value would be my second cofactor. And now we'll deal with the final cofactor, okay? And I know me talking about this abstract is a little bit weird, but I promise you we will do some examples here, okay? Now we're going to deal with minor 1, 3, which means first row, third column. To do that, I'm still dealing with coefficient C, but not directly yet, but still scratch out the column and the row it's in. Minor 1, 3 is just the determinant of what's left, DEGH. So once I evaluate that, I can find the cofactor 1, 3, which since I dealt with the third coefficient in the first row, my sign matrix says it should be positive of that minor, so that would be my cofactor 1, 3. Now, I'm still going to edit this one more time because this is where this comes in here. So let's see. A, B, C, F, I. Okay. So now, once you've found all your cofactors, to find the determinant, you take the value of the coefficient in row 1, column 1, which was the value, what you used to get cofactor 1, 1. you'll take that coefficient times cofactor 1, 1 plus the second coefficient times cofactor 1, 2 plus the third coefficient times cofactor 1, 3. And that'll be your determinant. And this, when you do the expansion of cofactors for the final step, is just straight addition. You don't have to worry about negating signs at that time because you already did it in your cofactor step. So we'll get into some examples here and I'll show you what the heck I'm actually talking about. Just to aid us, I will leave up the sign matrix. Alright, so let's do this here. Alright, so there you go. There's matrix A, entries 12, 4, negative 1, negative 2, 3, 2, 5, 8, 1. I'm just going to deal all with row 1. So the first thing I want to do is find my minor 1, 1. Minor 1, 1. So that means I'm dealing with the first row, first column. So I'm not going to worry about dealing with the coefficient of 12 just yet, but I am going to strike out the column and the row that it's in. Alright, so we're going to take the determinant here of what's left. That'll be, of course, 3, 2, 8, and 1, which would end up being 3 times 1 is 3, minus 2 times 8 is 16, which would be negative 13. So there's minor 1, 1. Now, to find cofactor 1, 1, I'm going to take that negative 13, and since I dealt with the first coefficient in the first row, look at the sign of it. It's positive of whatever that minor is. So positive of negative 13 is still negative 13. So cofactor 1, 1 is negative 13. And you can do this in columns if you so choose, or even diagonally. That is perfectly permissible, but it's usually easiest to do the first row. Now let's find minor 1, 2. Minor 1, 2. Whoops. Let me rebuild this here. Alright, so minor 1, 2, I'm going to, of course, deal with, that means first row, second column. I'm dealing with that 4 coefficient, but I'm not multiplying by it just yet. So strike out the column and row it's in, you'll take the determinant of whatever's left. So that'll be a determinant of negative 2, 2, 5, and 1. So now, let's see, negative 2 times 1 is negative 2, minus 2 times 5 is minus 10, which would give me negative 12. Well, now to find my cofactor 1, 2, I worry about where the coefficient itself was that we dealt with. The coefficient 1, 2, according to my sign matrix, should be negative. So I'll negate that minor of negative 12 and I'll get a cofactor of positive 12. Now let's find minor 1, 3. Minor 1, 3, whoops, I need to rebuild this again here. Okay, 3/8. So I'm going to deal with that negative 1 coefficient, but I'm not yet dealing with multiplying by it. So strike out the row and column it's in, it's just going to be the determinant of whatever's left. So that'll be negative 2, 3, 5, and 8. So let's see, I'll take negative 2 times 8, which is negative 16, minus 3 times 5, which is minus 15. Well, that would be negative 31. Now to find, so that's minor 1, 3. To find cofactor 1, 3, all I need to do now is take where that coefficient was, look at my sign matrix. It would be positive of whatever my minor is. So positive negative 31 is negative 31. All right, so now let's rebuild this one more time here. Twelve, 4, negative 1. 2, 1. Now, since I found all my cofactors, this is where I deal with the coefficients in row 1. So the determinant is going to be equal to that 12 times my cofactor 1, 1, which would be negative 13, plus that 4 times my cofactor 1, 2, which would be 12, plus that negative 1 times my cofactor 1, 3, which would be negative 31, which would be equal to negative 156 plus 48 plus 31. Now I'm just going to take all this, add it up, we'll be done. I would get negative 77. So the determinant of this matrix would be negative 77 by expansion of cofactors. All right, what's next? Okay, so we're going to evaluate the determinant of A here. So let me just set up a separate determinant notation here so I don't have to keep trying to rebuild the original matrix, because we'll be here forever if I do that. If I don't do this, I should say. Alright, so we're still going to do expansion of cofactors. Much like we could with the other method, if you have a row or a column with 0 in it, that's great. That's going to make your life 100 times easier. Because 0 times anything is what? 0. So we really only need to worry about 2 cofactors, don't we? So this is row 3, column 2. So let's find minor 3, 2. Again, you could pick any row or column, so strike out, of course, the column and the row that it's in, you get the determinant of what's left. So minor 3, 2 is the determinant of 5, 4, 4, 1. So that's going to look like 5 times 1, which is 5, minus 4 times 4, which is 16, which would be negative 11. Now, define cofactor 3, 2, which is really what we need here. Take the sign of where the location was of the coefficient you used. So according to the coefficient matrix, we need to negate this minor. So negative 11 would actually be positive 11. That's cofactor 3, 2. Now let me rebuild this determinant thing here. Now we'll find minor 3, 3, so that'd be the third row, third column. So we're dealing with the coefficient of that one, but we're not multiplying by anything just yet. So strike out the column and row it's in. There's the determinant of whatever's left. That'll be your minor 3, 2. So it'll be the determinant of 5, negative 9, 4, and 2. Alright, so 5 times 2 is what? That's 10. Minus negative 9 times 4, that'd be plus 36, which would actually be 46. Alright. So now we need to find cofactor 3, 3. To find that, according to the coefficient matrix where I dealt with that coefficient of 1, the sign should be positive. So if I take positive that minor 46, my cofactor will also be 46. So now this is where it gets a lot easier. I'll just take that coefficient of 1. So the determinant of A would equal that coefficient of 1, which is just simply going to be 1 times my cofactor of 3, 2 of 11, plus 1 times my cofactor of 3, 3, which is 46, which would give me a determinant of 57. So the determinant for this matrix would end up being 57. All right, what's next? Okay, so here's the matrix A with entries 0, 5, 2, 10, 13, negative 4, negative 5, 4, and negative 1. It's nice because we have row 1 with a 0 in it, so we can definitely use that row. So let's make up the determinant notation first so we don't have to keep rebuilding the matrix. 0, 5, 2, 10, 13, negative 4, negative 5, 4, negative 1. Okay. Well, 0 times anything is always 0. We can just deal with 5 and 2. So that means we need to find minor 1, 2 since we're dealing with the first row, second column. So find minor 1, 2. So we're not going to multiply by 5 yet, but we'll strike out the column and row that it's in. Your minor is just simply the determinant of what's left. So the determinant of 10, negative 4, negative 5, negative 1. Well, 10 times negative 1 is negative 10, minus negative 4 times negative 5, that'd be minus 20. Well, that would give you negative 30. Now we need to find cofactor 1, 2. Well, the coefficient I used, the sign matrix says to negate that. So if I negate my minor of negative 30, that means my cofactor 1, 2 will be positive 30. Now let's see. Let me rebuild this here. Let's go ahead and find minor 1, 3 then. Minor 1, 3, we're going to deal with that 2 coefficient, but we're not going to multiply by it just yet. So strike out the column and row that it's in. minor 1, 3 will simply be the determinant of what's left, which would be 10, 13, negative 5, and 4. So now, let's see, find the determinant. 10 times 4 is 40, minus 13 times negative 5. So that would be positive 65. So that would end up being 105. So now to find cofactor 1, 3, where that 2 coefficient was, according to my sign matrix, it's positive. So positive minor 1, 3 would still give you a cofactor of 105. Now, all we have to do here, I probably didn't need to rebuild that. That's okay. I just need to deal with, now to find the determinant, take the coefficients in row 1, so that would be 5 times my cofactor 1, 2, which is 30, plus that 2 times cofactor 1, 3, which is 105, which would end up giving me 150 plus 210, which would end up giving me the value of the determinant to be 360. So the determinant in this case would be 360. All right, next one here. There you go. So matrix A is 1, 16, negative 2, 20, 4, 2, 7, 1, negative 4. We'll just deal with row 1. So let's go ahead and find minor 1, 1. Well, first let's set up the determinant notation. That way I don't have to keep rebuilding the matrix and looking back at the book to see what the numbers were, because that'll take us forever. Alright, so let's find minor 1, 1 first, which is going to be where that 1 coefficient is. So take out the column and the row, and that's just the determinant of what's left. So minor 1, 1 is the determinant of 4, 2, 1, and negative 4. So 4 times negative 4 is negative 16. Minus 2 times 1, that'd be minus 2, which would equal negative 18. Now to find cofactor 1, 1, we're going to deal with that minor. So that 1 coefficient, according to the sign matrix here, the coefficient matrix, it should be positive. So you'll take positive negative 18, which is negative 18. That'll be your cofactor. Now let's deal with minor 1, 2. Alright, so minor 1, 2, we're going to deal with that coefficient of 16. So take your marker here, or pencil, whatever, strike out the column and the row that it's in. That's going to be the determinant of, wrong color. That'll be the determinant of 20, 2, 7, and negative 4. So 20 times negative 4 is negative 80. Minus 2 times 7, that'd be also minus 14. which would end up giving you negative 94 for your minor. So minor 1, 2 is negative 94. Now let's find cofactor 1, 2. Well, according to the coefficient matrix, I need to take the negative of whatever my minor was. So negative 94 would be positive 94 for my cofactor 1, 2. Now let's go on to minor 1, 3. We'll rebuild this here again. Alright, so minor 1, 3 is where that coefficient negative 2 takes place. So just go ahead, strike out the column and row it's in. And your minor 1, 3 is simply the determinant of what's left. So that's going to be the determinant of 20, 4, 7, and 1. Which would be 20 times 1, 20. Minus 4 times 7, which is 28. So 20 minus 28 is negative 8. So let's find cofactor 1, 3. Now, where that negative 2 is, according to my sign matrix, I need to keep the result of my minor positive. So if I take positive negative 8, that's still negative 8 for my cofactor. So now I found my 3 cofactors. Now we deal with the coefficients to find the determinant. So my first coefficient was 1, so just 1 times cofactor 1, 1, that'd just be negative 18. Plus, I'll take my cofactor of 16. I'll take my coefficient of 16 times my cofactor 1, 2 of 94. Plus, I'll take my coefficient of negative 2 times my cofactor of negative 8, which would give me negative 18 plus, let's find 16 times 94. That's going to be a hideous result. Alright, so that's 1,504, then plus 16. Alright, so the determinant of this one is 1,502, or 1502. So the determinant comes to 1502. What's next? Oh, good one. Alright, so here is matrix A with entries negative 4, 0, negative 1, 0, 8, 9, 0, 5, 2. Nice one, because we have a column here that has 2 zeros. So if we stick with column 1, we only got to deal with one determinant, which is nice to get our minor. So we're going to, of course, let's set up the determinant notation to make life easier. Negative 4, 0, negative 1, 0, 8, 9, 0, 5, 2. Okay. So define minor 1, 1, we're just going to take where that negative 4 is. We're not going to multiply by it yet. But we're going to take where it is. We're going to strike out the column and the row that it's in. Minor 1, 1 will simply be the determinant of what's left, which would be the determinant of 8, 9, 5, and 2, which would be 8 times 2, which is 16, minus 9 times 5, which is 45, which would end up giving you negative 29. Now to find cofactor 1, 1, find out where that negative 4 is in relation to your coefficient matrix, which tells us we need to take positive times whatever the result was for our minor. So positive negative 29 is still negative 29. So that's our cofactor. Now we only got one cofactor to deal with, so we can go straight to the determinant. The determinant would equal that coefficient of negative 4 times that cofactor of negative 29, which would end up equaling positive 116. So you get a determinant of 116. This is where expansion of cofactors is actually kind of a nice method. Sometimes it seems like it saves a little more time, but not much. Alright, 4 more problems here. La-di-da-da. Let's see. 3, 13, and 4. Okay. So there's matrix A with entries 8, 2, 9, 12, 3, 9, 3, 13, and 4. So let's set up the determinant notation, which would be 8, 2, 9, 12, 3, 9, 3, 13, and 4. Okay. Well, let's just pick a row or column or a diagonal and do it. I'm just going to pick row 1 like always. So let's find minor 1, 1. Minor 1, 1. So take where that 8 is, strike out the column and the row that it's in. We're not going to multiply by any coefficients yet. It's just the determinant of whatever's left. So that'd be the determinant of 3, 9, 13, and 4. Alright, so 3 times 4 is 12, minus 13 times 9, which would be 117, which would be negative 105. So there's minor 1, 1. Now we can easily find cofactor 1, 1. To find cofactor 1, 1, figure out where that coefficient is in relation to your coefficient matrix. That tells us it should be positive, the result of the minor. So positive negative 105 is still negative 105. Alright, so there's our first cofactor of negative 105. Let's find minor 1, 2, since we're going to stick with the first row. So that coefficient of 2 is where we're going, so strike out the column and the row that it's in. Now it's just the determinant of whatever's left. So that'll be the determinant of 12, 9, 3, and 4. So 12 times 4 is 48. Minus 9 times 3 is 27. 48 minus 27 equals 21. Now to find cofactor 1, 2, take where that 2 is in the matrix, take where that second number is in the first row, relate it to your coefficient matrix, So this tells me I need to take negative of my minor. So negative of 21 is negative 21. So I have a cofactor of negative 21. Then let's find minor 1, 3. Which would be equal to, well, let me rebuild this real quick here so we have a good picture of this. All right. So we're going to deal where that coefficient of 9 is, but we're not going to multiply by it just yet. So take your marker, strike out the column and row that it's in, and then you have the determinant of what's left. So that would be the determinant of 12, 3, 3, 13. So that's going to end up being 12 times 13 is 156. Minus 3 times 3, so that's minus 9. 156 minus 9 is 147. So that's minor 1, 3 is 147. Now to get cofactor 1, 3, we are going to take where the sign of 9 is. According to the coefficient matrix, it should be positive whatever the result of the minor is. So positive 147 is just that. So now we have our 3 cofactors. We can now proceed to find the determinant. So the determinant is going to equal that coefficient of 8 times the first cofactor of negative 105 plus 2 times my second cofactor of negative 21 plus 9 times my third cofactor of 147. So 8 times negative 105 is negative 840. Then 2 times negative 21, that's minus 42. Now we need to figure out 9 times 147, which is not going to be a pretty number. $1,323, yep. Which should give us a simple result here in a second. Which should give us 441. So the determinant by expansion of cofactors is 441. Okay. We just did that one. Let's do this one here. Alright, so here's matrix A with entries 3, 12, negative 1, 10, 9, 0, negative 5, 6, negative 2. We have a row or a column with a 0, which is going to make our lives a little bit easier because we can stick with that row or column. I'm actually going to deal all with column 3 this time, so it's going to work a little bit differently, but it's the same process. Let me set up my determinant notation first. That might help us. So I'm going to find minor 1, 3. That denotes that I'm starting in the first row, third column. So I'm starting where that -1 is, but I'm not multiplying by it yet. So strike out the column and the row that it occurs in. That's just going to be the determinant of what's left, which would be the determinant of 10, 9, -5, and 6. So 10 times 6, that's 60. Minus 9 times -5, that'd be plus 45, which would give you the minor of 105. Now we can go ahead and find cofactor 1, 3. According to where that coefficient of -1 is, it should be positive whatever the result of my minor is. So positive 105 is still positive 105. So that's my first cofactor. We can skip the second cofactor because it's 0. 0 times anything is 0. But let's deal with our third cofactor right away. Actually, it'd probably help if I rebuild it, wouldn't it? So you can see what the heck we're talking about. So yes, we are skipping that 0 cofactor, that 0 part, because 0 times anything is 0. But we're sticking with the third column here. This will be actually minor 3, 3, because this denotes the third row, third column. So we're going to deal with where that coefficient of -2 is, but we're not going to yet multiply by it. So strike out the column and the row that it's in, and then you should end up getting the determinant of what's left for your minor. So the determinant of 3, 12, 10, and 9. So let's see, that determinant would be 3 times 9 is 27, minus 12 times 10, that'd be minus 120. So let's go ahead here and take 27 minus 20, minus 120, excuse me. That'd be -93. Now, I need to find cofactor 3, 3. So according to where that coefficient of -2 was, I need to keep positive of the result of my minor. So positive -93 is still -93. Alright, so I got both the cofactors I need now. Now I can go ahead and proceed to do my multiplication. So to find the determinant, it's going to be that coefficient of -1 times my cofactor of 105 plus that coefficient of -2 times my cofactor of -93. So that would end up being -105. This would turn into plus since you have two negatives. That'd be plus 186, which would end up giving me a determinant of 81. So the determinant in this case for this matrix would in fact be 81. I got two more, then we're done for the day. Alright, what's next? Alright, so here's matrix A with entries -3, 2, 20, -10, 9, 18, 11, 15, 12. So we're going to again first set up our determinant notation for this matrix. Okay, I think we'll just stick with row 1 again. So let's go ahead and find minor 1, 1 to start with. Minor 1, 1, so that's where the coefficient of negative 3 is. Strike out the column and the row that it's in. Your minor 1, 1 will simply be the resulting determinant of what's left. So that'll be the determinant of 9, 18, 15, and 12. So let's see, 9 times 12 is 108, minus 18 times 15. Let me figure out what the heck that is. I think it's 270, I believe, but let's make sure. Yeah, so minus 270. Alright, so now let's just do 108 minus 270. That'd be negative 162. So that's minor 1, 1. Let's find cofactor 1, 1. So according to where that negative 3 is in the matrix, I should have a positive result of my minor 1, 1. So positive negative 162 is still negative 162. Now let's proceed to finding minor 1, 2. So that's going to, of course, let me rebuild this here a little bit. So now we're going to find where that 2 is in row 1. We're going to strike out the column and the row that it occurs in, which will give you the determinant of negative 10, 18, 11, and 12. So let's see, negative 10 times 12 is negative 120, minus 18 times 11, which would be 198, which should end up giving you negative 318. Now let's find cofactor 1, 2. So we got minor 1, 2 as negative 318, but what about cofactor 1, 2? Well, according to our sign matrix where that 2 occurs, it should be negative of the result of minor 1, 2. So negative 318 turns it into a cofactor of positive 318. Now we can find minor 1, 3. All right, so let's find minor 1, 3. So we're going to deal with where that 20 coefficient is, or 20 constant is. So strike out the column and row that it's in, and then you'll have the determinant of what's left for your minor, which would be the determinant of negative 10, 9, 11, and 15. So negative 10 times 15 is negative 150. Minus 9 times 11, well, that's minus 99, which would give you a minor of negative 249. So we got the minor as negative 249. Now let's find cofactor 1, 3. Well, according to my sign matrix, my coefficient matrix, it should be positive of the result of the minor. So positive negative 249 is still negative 249. All right. Now that we got that, let's go ahead and figure out the actual determinant. So the determinant is going to equal my coefficient of negative 3 times my first cofactor of negative 162 plus my coefficient of 2 times my second cofactor of 318 plus my coefficient of 20 times my cofactor of negative 249. So now let's just do all this wonderful math here. So 486 for the first number plus 636 minus, this will definitely throw it negative, minus 4,980. Let's see what our final result is for this. Negative 3,858. Oh my goodness. Negative 3,858. That is the determinant for this matrix. Quite a large negative number. And I got one more and then we should be done. All right, last one here. All right, there you go. There's the matrix of 15, 4, negative 10, negative 10, 0, 6, negative 8, 2, and negative 14. So let's go ahead here, set up our determinant notation for this first. Just take all this, put it into our determinant notation. All right. Notice we have a row with a 0 in it, a row or a column, however you choose to look at it. I'm going to say we go with row 2 this time. We'll go with row 2 and expand those cofactors. So that means 0 times anything is 0, so we're only going to have 2 determinants to deal with. I mean, yeah, 2 determinants and 2 cofactors to deal with. So where that negative 10 is, we're going to, well, first, let's find minor 2, 1. Which means we're in the second row in the first column. So where that negative 10 is, strike out the column and the row it occurs in. For minor 2, 1, you'll just end up having the determinant of 4, negative 10, 2, and negative 14. Which 4 times negative 14 is negative 56. Negative of negative 10 times 2 would be actually positive 20. So minor 2, 1 is negative 36. Now let's find cofactor 2, 1. So according to where that negative 10 is, according to my coefficient matrix, I should negate the result of my minor. So negative 36 would be positive 36. So cofactor 2, 1 is positive 36. All right, let's rebuild this a little bit here. Alright, so we don't need to deal with 0, but let's deal with where the 6 is. So that's going to be minor 2, 3. So this is minor 2, 3, since it's in the second row, third column. So where that 6 is, strike out the column it's in and the row that it occurs in. The result will be the determinant of what's left. So that would be 15, 4, -8, and 2. So 15 times 2 is going to be 30, minus 4 times -8, that'd be plus 4 times 8, which would be 32. So the minor would end up being 62. Now let's find cofactor 2, 3. According to where that 6 is in the matrix, according to my coefficient matrix, I should negate the result of my minor. So cofactor 2, 3 would be -62. Alright, so now all we got to do to find the determinant is take the coefficients and multiply them by the cofactors. So the determinant itself, let's see, so the coefficient of -10, since we dealt with cofactor 2, 1, the coefficient will be -10 times my coefficient of 36 plus, now I'll take my coefficient of 6 times my cofactor of -62. So -10 times 36 is -360. 6 times -62, let's figure out what the heck that is. That'd be -372. Which should give us a final result here very shortly. -732. Yep. So the determinant of this matrix is going to be -732. So that's it for basic finding determinants. The next two lessons, well really the next several, will be about applications of determinants. The very next lesson, we're actually going to use determinants to find the area of a triangle in the coordinate plane. There's a way to do that with determinants. So I hope everyone has a great day. Take care.